Okay, so in the first video we used the nth term rule to find the value of terms at different positions in a given sequence. Now we're going to learn how to generate or find the nth term rule for a given sequence. So here's an example here. Find the nth term rule. What is that t of n equals something n plus or minus some other number? What is that rule for the sequence 3, 7, 11, 15? The way to approach these is to write out the sequence and to just bounce from one term to the other, and note that from 3 to 7 is plus 4, 7 to 11 is plus 4, plus 4. So we know that our term-to-term rule is plus 4, okay? So we will always start by writing Tn equals 4n from this 4 here. Always start with that statement, and then we plug 1 into for n, so that this statement implies that T1 is equal to 4 times 1 is 4, okay? But our sequence starts with 3, so we need to find out now what we need to do to this value of 4 or 4n, so that we can turn our 4 into a 3. And to turn our 4 into a 3, we need to subtract 1. So our true nth term rule, Tn, is equal to 4n, which we started with, but minus this value of 1. And that's the method to generate the nth term rule. Okay, and we can check to say, okay, is this right, because we know the second term is position n is 2 is 7, so if we plug 2 into this equation, we get 4 2s are 8, minus 1 is 7, so that's fine. And if we look for the third position, we know it's 11, so we're looking for 11, so 4 by 3, 3 is n, minus 1, that's equal to 11. So we've generated the correct nth term rule for that sequence. And here's a second example. Find the nth term rule of the sequence 10 to 7 to 4 to 1 to minus 2. Okay, and hence find T20, that says there, okay? The term value at the 20th position. Okay, so to go from 10 to 7 is we subtract 3. And from 7 to 4 we subtract 3. So we start by writing Tn equals minus 3n, okay? Then we go on always to let n equal 1 and find what that value is, okay? Now, that's saying that the first term is minus 3, but it's not, it's 10. So we need to find out what we need to do. What do we need to add or subtract to make minus 3 turn into a 10? And the answer to that is plus 3. So Tn is actually equal to the minus 3n, which we started with, sorry, plus 13, plus 13. And that is the nth term rule for that sequence. Okay? And so T20 is, we let n equal 20, is equal to minus 47. And the third type of problem we might meet using the nth term rule is if we know the nth term of a sequence, we can find which term any given number is. Okay, so they'll give us a number and say what term is that? Where is it? Okay, what position is it in the sequence? Okay. For example, the nth term of a sequence is given by Tn equals 5n minus 4. Which term of this sequence would be equal to 21? What's its position? Its n value. Okay. Well, the term at the n value we don't know. The term value is 21. Okay. But the term value for n is 5n minus 4, and that must be equal to 21. So 5n must be equal to 21 minus 4 comes over as plus 4 gives 25. So n is equal to 5. So at the fifth position, the value in the sequence is 21. That's the fifth term's value is equal to 21. Now we look at problems associated with sequences formed from shapes. So we're given a problem here where we have a photo frame with 3 rods and another photo frame that holds 2 photos, and that's got 5 rods, and a third photo frame which holds 3 photos, and that has an amount of rods. Okay, so we're asked to draw the photo frame which would hold 4 photos if we follow this pattern here. Okay, and that would look like this. Okay, and then we're asked how many rods it would be needed to create a frame that holds 5. Well, the best thing to do is to draw your pattern out, count the rods 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 9, 11. Okay, so you can just say the fifth one needs 11 rods. Okay, now we're asked then to find an expression for the number of rods in the nth frame. In other words, find the nth term rule. Okay, so we know that we have, if we take these values down here, we've 3, 5, 7, 9, 11 is the sequence of rods. And what's the difference between those? 2, 2, 2, 2. Okay, so Tn is equal to 2n. Sub in n is 1. Tn is equal to 2, but it starts with 3. So how do I go from 2 to 3? I add 1. This is the nth term rule for this sequence of rods. Okay. Then we're asked, which frame uses 41 rods? Okay, so we're looking for n, okay? Where is it up the line? Which frame is it that's using that the value in the sequence is 41? Where is that? So Tn, you let Tn equal 41, but we know that Tn is equal to 2n plus 1, so that's equal to 41. So 2n is equal to 40, because we took the 1 over, and n must be equal to 20. So the 20th frame in the sequence its value is 41, or uses 41 rods. Okay. Now, further question, is it possible to make one of these frames using 56 rods? So we let Tn equal 56, we find that n is equal to 27.5, so that's not a whole number, so no, it's kind of half a rod. We're not dealing in half rods, we're dealing in whole rods, so no, it wouldn't be possible to make a frame using 56 rods. Okay, let's look at quadratic sequences. And quadratic sequences, when we look at their nth term rule or formula, they contain n squared as the highest power if n appears. Okay, and they're called quadratic sequences. And we're going to take a look at this notion of first and second difference. So let's say we have a quadratic sequence whose nth term rule is Tn equals 2n squared minus n. So let's generate the sequence. So if we let n equal 1, we'll get 1 here. N equal 2, you can put 2 in here. 2 squared is 4, times 2 is 8, minus 2 is 6, and so on. So you can generate the different numbers in the sequence. And if we look at the difference, the first difference between these numbers, between 1 and 6 is 5, 6 and 15, 9, 13, 17. But if we then go on to look at the second difference, the difference between these two values, the 5 and the 9, that's 4, the 9 and 13 is 4, 13 is 4, we can see that the second difference is constant. Okay? And what we also want to make note of or realize is that in the nth term rule for this sequence, the coefficient of the n squared is 2. Okay? And the second difference generated by this sequence is 4. And it's always the case that the coefficient, the number beside the n squared value, is always half the second difference. Always half. So if that was 3, it's guaranteed that the second difference would be equal to 6, and so on. So it's just something to note for future reference.